Hello everyone, welcome to the 2024 AMC 8 problems. Today we're discussing problems 11 through 17. So let's just get started. Problem 11. The coordinates of triangle ABC are 5, 7, 11, 7, and 3, y, with y greater than 7. The area of ABC is 12. What is the value of y? So as you know, the area of a triangle is its base times height over 2, and we're given that is equal to 12. Now our y coordinate here is what determines our height. We know the base is just the distance between A and B, which is 11 minus 5 equals 6. So we have 6 times height over 2 equals 12. This is equal to 3 times height, which means our height equals 4. And the height is just equal to C, the distance from C to the segment AB. And that's just equal to y minus 7. And that means y equals 11. So the answer is D. Problem 12. Rohan keeps a total of 90 guppies in 4 fish tanks. There's one more guppy in the second tank than the first tank, 2 more in the third tank than the second tank, and 3 more in the fourth tank than the third tank. So we have 4 tanks. Let's say the first tank has X guppies. There's 1 more in the second tank than the first tank, so it's going to be X plus 1. 2 more in the third tank than the second tank. It's going to be X plus 3, not X plus 2, because we have to add the 1 right here. And 3 more in the fourth tank than the third tank, so it has 3 more, which means X plus 6. And we're given that the total is going to be 90. These add up to 90. We add up the x's, we have 4x. We add up the constants, we have plus 10, which means 4x plus 10 equals 90. 4x equals 80, which means x equals 20. So the answer is not A. It's x plus 6 because we're asking for the fourth tank. So 20 plus 6 is going to be 26. So the answer is E. Problem 13. Buzz Bunny is hopping up and down a set of stairs, 1 step at a time. In how many ways can Buzz Bunny start on the ground, make a sequence of 6 hops, and end up back on the ground? For example, you can go up, up, down, down, up, down. So the first thing to notice is that we're going to have the same number of hops up as down, obviously, because we have to end up at the start, which means we're going to have 3 ups and 3 downs. I'm just going to use U and D. So we can just start listing some possible sequences. The first step is always going to be U, and the last step is always going to be D, because we need to. The second to last step is going to be on the first step, and the second step is going to be also the first step. So we can just start listing. If we go up, then down, and up, down, that works. We can up. Let's just do all the cases where the second step is down. We have to go up, down. We have up, down. We have to go up again. And we can reverse these two to get this sequence. And now I believe that is all for sequences starting with up, down. Now we have to go up, up. We could go up again, and we have to go down 3 times in a row. We up, up. We can't do up again, so we'll go down. And the last one must be down, which means this can be up, down. And again, you can switch these two. We have up, up, down, down, up, down. So this should be all the cases. We exhausted through all the ones starting with up, down, and all the ones starting with up, up. And the answer should be 5, B. There's 5 sequences. Problem 14. What is the distance of the shortest route from A to Z? So this is an AMC 8 problem, which means the shortest path is not going to be just a straight line. But what we can do is we can rule out some paths that are not optimal. So if we take this path from A to M, we can take 8 miles, or I don't know, let's just say miles. But we can also go A to X to M, and that's shorter because that's 5 plus 2, which is 7. So we can actually rule out this because we know there's a shorter path there. And for this one, we can go, instead of going 10 from X to Y directly, we can go from X to M to Y to travel 8 miles instead of 10. So this can be ruled out. And similarly for 14, 6 plus 5 is less than 14, so we rule that out. For 17, 17 is greater than 5 plus 10, which is 15, so we can rule that out. And 25 is going to be less than 6 plus 5 plus 10, which is 21. So we can again rule that out. So now, coincidentally, we already left with the shortest path, which is A, X, M, Y, C, Z. So we just add up 5, 2, 6, 5, and 10. Add up these two is 7. Add up these two is 11 plus 10. And we should get 28. So the answer is A. Problem 15. Let the letters fly, bug represent different digits. Suppose fly, fly is the greatest number that satisfies this equation. What is the value of fly plus bug? So I'm just going to write the equation out here. So this is a 6-digit number, and this is also a 6-digit number. So we can split this into fly with 3 zeros at the end. So you could say fly 1,000 plus a fly, another fly. And fly 1,000 is just fly times 1,000. And fly is just fly times 1. So we can use the distributive property to find that this is equal to fly times 1,001. And this makes it easier because this other side can also be written as bug 1,000 plus bug, which is equal to bug times 1,001. This is a times, by the way. So now we can actually cancel out 1,001 from both sides. And now we just have 8 times fly equals So now we have two 3-digit numbers where one of them is 8 times greater than the other. And we're asking for the largest value that satisfies this. So we can count down from 1,000 to find multiples of 8 that work. So we know 1,000 is going to be 125 times 8. That doesn't work because it's not a 3-digit number. 992 is the next smallest. This is going to be 124 times 8. That does not work because 9 appears twice. We have to have 6 distinct digits. We go 1 down to get 984. This becomes 123 times 8. And we do have 3 distinct digits, or 6 distinct digits. 1, 2, 3, 4, 8, and 9. So this is going to be our answer. And we're asking for fly plus bug. So we just add 984 plus 123. Do some addition, and we get 1007 as the answer. So it is C. Problem 16. Min enters the numbers 1 through 81 to the cells of a 9x9 grid in some order. She calculates the product of the numbers in each row and column. What's the least number of rows and columns that could have a product divisible by 3? So if you have some numbers, I'll just like list some numbers down. If you take the product of them, if a single one of these numbers is divisible by 3, then the product must also be divisible by 3. So we want to minimize the numbers of rows and columns that contain at least one multiple of 3. And there are 27 multiples of 3 between 1 and 81. And we want to fit them in a 9x9 grid. Now, an intuitive way is to just pack a lot of them into one quarter or one corner. If we have a 5x5 grid here, this is 5x5. So this takes care of 25 numbers, and this gives 5 plus 5 equals 10 rows and columns that contain a product divisible by 3. But we still have 2 more. So we know the answer is greater than 10 because this is optimal. So we can actually just put them, the remaining 2, right here to create a 1x2 grid. And this creates another column that contains a multiple of 3. So it is 1 more than 10, which means it is 11. So the answer is D. Problem 17. A chess king is said to attack all squares one step away from it. I'll let you read that. For instance, a king on the center square of a 3x3 grid attacks all 8 other squares as shown below. Suppose a white king and a black king are placed on different squares of a 3x3 grid so that they do not attack each other. How many ways can this be done? I'll just draw a grid like so. So let's just casework on, let's say, where is the white king? So the white king can either be in one of these 4 corners, in one of these 4 sides, or in the center. Notice that if you take the corner, for example, it is symmetric to all 3 other corners. So we can just take this and multiply it by 4. So let's say the white king, W, is here. then the black king cannot be in any of these squares, so they must be in any one of these 5 squares. So there are five options times 4 because there are 4 corners. They can also be in one of the edges, and this clears all of these squares. So it can be one of these 3, which means there are 3 times 4 for the 4 sides. And finally, the white king can be in here, but the black king cannot be any of these 8 squares because it attacks it, so there's actually no cases for this. So if we just add them up, we get 20 plus 12 equals 32. So the answer is E. Alright, thank you guys for watching. I'll see you guys in the next one.